Hello, hello. Welcome back, everyone. So, as I promised, I came within some time only. I came back within some time only. Uh, yeah, today we can continue with our blind 75 quest and try to make as much progress as possible. So, the intention is to get done with those with that blind 75 list and learn as many patterns as possible. Like in the meanwhile, it's important for us to understand how those problems are being solved, and not just those 75 problems, but any problem similar to that. If that arrives in the interview, or if we get that in the interview, then we should be able to solve it. That's the intention, or that's the goal. I think we are making good progress in the right direction for that goal. Let's keep doing the same thing. I noticed that in one of the while solving one of the last problems yesterday, my mic was muted and I didn't notice. Um, so I'll try to explain that problem, explain the solution for that problems once, and we can start from there and and see how it goes. Let me know if any of you have any questions. Feel free to just comment in the chat. Let's get started. Yeah, let's get started. So before this problem, I told I'll let's go with the previous one. So let me add these things into my add the links of the uh, problems that we are solving or working on once. Okay, this is the link. this is the link for this is the link which contains all the problems that we are working on in the stream. So yeah, my voice is stuck as well. So it's still early in the morning here. So let me see. Let's let's start soon. Give me a couple of minutes so that I can have all the setup and then we can start without any other thing. Okay. Yeah, now I think I'm all set. We can start from the problem yesterday. So, yeah, in this problem, we solved yesterday to just to provide a recap. We solved this. We sorted by frequency, and like we are solving the most occurring problems first. So, welcome, officially welcome. Let's try to grind as many problems as possible today. Most important thing is understanding rather than covering a lot. I know we need to cover and finish it. Like I'm emphasizing that again and again. But in the meantime, if we finish it without understanding, it's of no use. So let's try to understand each of the problem and solve it along with. Okay, here you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? That's the question. So in every step, we can either climb to the next one step or we can climb two steps after that one. So that's the only possibility. So how many different possible way? Like let's say if we climb the first step by using one step, then that would follow a totally different path compared to climbing two step in the beginning itself. And the same way, like after first step also what we choose, whether we choose to climb one step or two step, that probably creates another combination. So based on that, how many different combinations or different ways that we can climb n steps? That's the question. So here, like we need to identify base cases in these kind of problems. Base cases are how many ways we can climb if it is only one step. If the step count is only one, we can climb it only in one particular way. We just have to climb one step. What if there are two steps? If there are two steps, there are two ways that we can climb. So here in this example, you can see they have given we can climb either one step plus one step, or we can climb two steps at once. So those are the two ways that we can climb, and they have given the example for three steps also. But three steps, it is not the base case. For one and two, those are the base cases. So three steps we can climb it in a way 1 plus 1 or 1 plus 2 or 2 plus 1. Like first we will take one step and then two steps, or first we will take two steps and then one step. So now the problem is understood. But how can we arrive or make a general formula for this one? So for three steps, we can notice that the way that we can climb to three steps is the way we can climb to 3 minus 1 step and 3 minus 2 steps, because either we can come to 3 from 3 minus 1 step, or we can come to 3 from 3 minus 2 steps. So the total combination possible, the summation of both, would form the number of combinations possible to climb 3 steps. So that's the main formula that I am using. So let's see, let's use the same logic here. So we identified the base case here. First, let's do that. If n is equal to 1, then we should return 1. And in the same way, we know how many ways we can climb two steps. That is also very fixed. So two steps can be climbed in only two ways. So we can have this as else if condition. Else if n is equal to 2, return 2. If not neither 1 nor 2, then return, as I said, we can call a recursive function here, return climb stairs of n minus 1 plus climb stairs of n minus 2. So this should give all the possible combinations of how to climb to n steps. So we saw that in the example 3. For 4 also it's the same thing. I'll show that in the execution as well. Let's run it and check. Okay, we can see that it's accepted. So now I'll show how the recursion is working. Let's print the values here, like which recursion is being called. System.out.println. I'm printing which recursions are being called here. So let me execute this, run this one. Now we can see std out n is equal to 2. N is equal to 2 is being called, and where is 1 actually? Okay, so for this one, for n is equal to 2, only two steps we will calculate. So n, like, what are we checking here? N minus 1 plus n minus 2 when n is equal to 2. So we came into this one, and then n is equal to 2 is printed, and then we just return when n is equal to 2, return 2. So let's say what is this case? This is for n is equal to 3. For n is equal to 3, we came to calculate 3, and then we are computing for n minus 1, which is 2, and then we are computing for n minus 2, which is 1. Now in the same way, if we add more cases, let's say n is equal to 4, then how many things will be executed? So if n is equal to 4, then we have to compute for n minus 1 and n minus 2, which is 3 and 2. And if n is equal to 3, again we need to compute for n minus 2 and n minus 1. So we need to compute for 2 and 1. So like that, we are computing for each of this. Okay. So now n is equal to 4. So this is so n is equal to 4, n minus 1 and n minus 2. Again, we need to compute for 3. For 3, while we are computing n minus 1 again and n minus 2. So we are re, recalculating for 2. If we increase this case or increase the number, this recomputation will get more and more. Like we will be calculating a lot of, we will be doing a lot of redundant computations there. Let's compute for 8. We can see here for 8 we did 7 and 6, and then 5 and 4 and 3 and 2, 2 and 1. So we need to compute all this. And then if we see, it has more things in the loop. So we have so many repeated computation for 4. We can see 4 and 4 and 4 and 5 so many times. So there are so many repeated computations or wasted recursive calls. That is the reason we can follow DP here, dynamic programming, and then have a kind of memoization. So this solution would not be sustainable for a longer. Uh, so now for 4 it works, or for 8 it works. If we give something like a bigger number like 20, like it's not bigger number actually, but still I think it will take a lot of time, or it will, yeah, for 20 you can see so many recursive computations are needed, and it is calling that so many times repeatedly. Okay, it's still not the end. You can see the cursor here, like it keeps going. Okay, so it is too much of wasteful computations, but still it's working. Let's do for a even bigger number, 40. It might not even succeed. So it keeps growing exponential in the exponential order when we double the value. So now it didn't even return the result. It said the time limit exceeded. So how do we fix this? As I said, we can use dynamic programming property here, and then memo is the already computed values. For that, let's use a map. So how do we use map? Let's create a map here. Private map of integer to integer. Like I'm storing what's the result for the value n. So I'll store it as a memo. So I'll initiate it in a constructor. So here memo is equal to new hash map. Okay, and I can store the initialization in this one only. Memo dot put for one step, for n is equal to 1, it's only one possible way. And now let's put another initialization for n is equal to 2. There's only two possible ways that we can climb the stairs. So once we have this memo created, so we don't need to look into this base cases here. We can return if memo dot contains key n, then return memo dot get n. Yeah, so now the base cases are handled here. We have replaced the base cases, and but we haven't added the result of this computation yet. So this should work for, like, no, it was not working for n is equal to 40, but if we make it as n is equal to 15, it should work still. Yeah, it still works for n is equal to 15, whatever the result is. It would give the result as 987, the output. So that's fine, but still it would fail for n is equal to 40. I mean, it would exceed the time limit. So we can see it will try to compute it. So it still exceeds the time limit. Why? Because we added memoization, but there's no change yet. We haven't added or we haven't saved the current computation in our memo. We just saved the initial cases or the base cases. So now let's do this one. So memo dot put of n is equal to, what should we put? The result of this computation. So we added that to, okay, not equals here. The syntax should be put of n. Okay, we are storing this value in that memo. Now we can return the same value, whatever we added in the memo. for memo of n. So now the recomputation wouldn't happen. Let's check for the smaller case again to start with. So smaller case was 8 that we checked. So we saw so many recomputation was happening to 8, happening with 8. So now let's see. And we still have the system dot, yeah, we still have the println. So here we are returning from the memo. So there will be recomputations, but we won't have this one. So what can we do is, let's add the system.println after this one, after this memo.get. So let's see now. Okay, for 8, this is the recursion that happened, 876543. And then again, let's check for 40. That's our 20 or whatever the next case. We can, for 15, it was so quick. So this is all recursion that happened. So base cases are not showing up because I added the println after the base cases. So let's check for the one which it was failing for now. So it was failing for 40. So let's see if time limit exceeds even now. No, it does not. So we get the value, we get the output, and the recursion is okay. For all the values, it called only once. The method is only called once. So yeah, we get the solution now. Whenever we need to compute, we won't recompute. Instead, if we have calculated already, we will just get it from the memo and return it as it is. We won't try to recompute the value by recomputing the lesser n values and everything. So this is much more performant. So this is called um, top-down approach. So because we are going from top to like n value to the base case, and we are computing n minus 1, n minus 2, and all that. So um, and we are using memoization. So there is a bottom-up approach as well that I can explain. So this and also the runtime complexity would be O of n for this. Yeah, because for every n value we are computing only once and then keeping it in the memo, and then we are returning it if it is used in the further computation. So let's see the bottom-up approach here. So if we do this, I'll just comment out this if we need it for reference. Just copied this method. Okay, let me take this one. So now, how do we compute the bottom-up approach? For bottom-up approach, so we still know the base cases. For n is equal to 1, the value is 1. For n is equal to 2, the value is 2. So we should compute from n is equal to 3. If n is equal to 1 or n is equal to 2, we can make it as return n, because that's n is equal to 1, return 1, n is equal to 2, return 2. So return n. Otherwise, what should we do? So otherwise, we need to compute from bottom up, as I mentioned. So how do we go about the bottom up approach here? Let's see. So for the bottom up approach, so now we need to go from 3 to n. We need to iterate from 3 to n, and then we know, let's see, we need a variable for current. Okay, so for int I is equal to 3, I less than or equal to n, because we need to compute until n, and then I plus plus. And then now when I is equal to 3, as we saw here in this example, it is the summation of I is equal n is equal to 2 plus n is equal to 1. So what do we do? So um, current value or current what can we take it as? Total stash is equal to previous 1 plus previous 2. We can mention it as previous 1 and previous 2. So here first we need to initiate these variables that we are using. So total stays. So total stays for the current value that we can initiate it as 0. So previous one is like we are starting from 3. So previous one will become 2. Previous one is equal to 2. And then in previous 2 will become 1. So now we are computing for 3. We have initialized previous 1 and previous 2 as 1 and 2 and total stays as 0. And here now once we compute the total stays, we will replace the value of previous 2 with previous 1, and then previous 1 we will replace it with the value of total stair. And then at the end, when we reach the end values, we should have the total value in total stairs. So let's return total stairs. And in this one there is no duplicated computation because we are going from top to bottom, sorry, bottom to top. So this is called bottom up approach. So let's run this. I hope everything looks good here. Okay, so this is accepted. So okay, we have the 40 use case also, and that is working. So let's submit it and see. Okay, this worked. Bottom up approach worked. We didn't try submitting for the top down approach. We can try that one as well. So I'm commenting this code and I'm uncommenting the previous version that we had. And let's run this one. Hope it's visible. Yeah, it's visible. So run it, just sanity check, and then I'm submitting it. Okay, so this one works as well. And why it is 0.66%? Any clue? Any guesses? Because I thought we thought this was much more efficient than this one. Okay, just we have a print statement here which is unnecessary. So let's remove this print statement and then try submitting again. Okay, so now it's much improved. So awesome. So we are done with the climbing stairs. This is a dynamic programming problem, but it is a simple problem among dynamic programming. So we are okay with this one. We are comfortable with this. So now let's move on to the next problem in the line 75. So that is this spiral matrix. So for spiral matrix, okay, before that, let me check my chat. Hi, Saram. Good morning. We mean store the repeated calculation so we don't calculate again, right? I see it. Yeah, yes, Saram, exactly. So it's basically like common sense in most of the scenarios. So we should see where we are doing the same thing. Like there is a potential that we are repeating our computations again and again, and we should try to come up with a strategy to avoid computing it again. Like we can do that either by going from bottom up, like from our approach. The easier way is to store it in some data structure and then use it later whenever we require to recompute it. So for memo we can only use the hash tables, or we can also use array. Since I mostly know arrays better, maybe now is the good time to learning about hashing. We can also use arrays because arrays is like index based data structure, right? So if we are memoizing the values only for integer values, then we can use the index itself, and we can store in that particular index, and then value in that particular index, and then reuse it. But let's say if we are not storing the continuous values, in our memo, like we are storing the values for 1, 13, 17, or 35 and all. So, and whatever the maximum value, let's say 200, but within 200 we are storing or recomputing only 5 or 6 values. Then it doesn't make sense to use arrays, because we are initiating array of size 200 and we are storing only 4 values out of it, just to look up by index. But if we use a hash map, it will we can store the key as like for which n we are computing what's the value, what's the computation value. So that would save a lot of space for us, and it makes sense. So that if we are like doing it for interview sake, that will definitely be a question. So if we are storing in an array, and if it is very sparse values in the array, then it's not ideal. But if we are storing continuous values, like in this climbing stairs problem, we are storing all the values until n. So it makes sense to use an array as well. So it wouldn't make any difference. I hope it is clear. Let's move on to the next problem now. Okay, so the next problem is LeetCode number 55 spiral matrix, and it's a LeetCode medium. Given a m cross n matrix, return all the elements of the matrix in spiral order. So they have given a matrix, and the order should be like this. Spiral means from left to right first, and then top to bottom, and then right to left, and then again bottom to top, and then again it follows the same order, right to left. Sorry, left to right. Same thing in this one also. In this, it is n cross n matrix. It is n cross m matrix because this has 4 columns and 3 rows. So, but we need to do the same thing. How should we think about this problem? So let's see. For this one, I'm thinking, since we need to navigate from left to right, and then top to bottom, and then right to left, and then bottom to top, we need a way to track all of our indices, basically, like left to right. So left one, we are starting with 0 here. So next time if we are going from left to right, again we will start from 0, but in a different row, not from that row. And also we already did top to bottom, so we don't have to go to this index. So somehow we should reduce the value of right. So when we go from left to right, so how do we keep track of all those values? That's the challenging part here, and we should do it a lot of without any recomputation. We should do it as efficiently as possible. So let's see. So what we can do is, and output is in the form of list of integer. So list of integer like this, 1, 2, 3, yeah, a single integer list. Let's first define the output. Okay, output is spiral order new new array list. Okay, once we have that, next thing is we need to check for the empty list. If it is an empty list, we can just return the result as an empty array list also. So if matrix dot length is equal to 0, then return the spiral order. Because this is an empty list as of now, we can return it as it is. Otherwise, now let's get to the computation. If the base cases doesn't satisfy, if the input is valid, then we need to compute. In order to compute, we will start with a left marker first. So left is starting from 0, and in right marker is at matrix dot length minus 1, and then int bottom, yeah, we will go from left to right, right top to bottom, and then okay, so let's keep the top would be 0 again, 0th row, and then there will be bottom value, which will be again matrix of 0, the length of the first column or first row, whatever. So yeah, that is this one. And then we can check while uh, what all we need to check. So we need to check where, like, these things, like when we are going from left to right, and then we are going from right to left. Again, we will go from left to right. Again, we will go from right to left. So we should do that only when left is less than or equal to right. Until then only we should do that. Should it be less than or equal or less than right? What if left is equal to right? Then also there is a possibility that top is not equal to bottom. Then just we need to print that one element in the middle. So let's consider it as left is equal to right, left is less than or equal to right, and top should be less than or equal to bottom value. Until then we will keep proceeding this. So now the first step is we need to go left to right. So how to traverse from left to right? Now let's say for int I is equal to 0 or I is equal to whatever the value in the left, I less than or equal to right, because right value is the matrix dot length minus 1. And then if we decrease right, left should go only until then. So let's decrease right also at some point. So when we will decrease, I'll explain. So here I is less than or equal to right and I plus plus. What should we do now? So we should add the elements to the our result. So spiral order dot spiral order dot add. What should we add here? So we have the matrix of, so this signifies left or right, which is the column number, but the row number is top. So this is the top left to top right. So top left to top right. So and then the value of the left is I. So we have assigned it as I. So I think this should give us what we are looking for. And then once we are done with all this, what we should do next time when we are doing this, we are done with the, okay, when we did left to right here, we did this left to right. So 3 is already printed. So we should do top to bottom, but 3 is already traversed. So top should be top plus 1. Basically, top would start from the next element. Here in this example also you can see here. We already traversed from left to right. 1, 2, 3, 4 should be printed. And then top value should change to top plus 1 or this one. So let's do this one. So why changing top after going left to right is that reason. So now we did from left to right, and then we should visualize. We next move is we should go top to bottom. If we just do top to bottom without incrementing the top now, we will print 4 two times. So in order to avoid that, we can increment top first, and then let's go top to bottom now. So how to go top to bottom? Again, we will follow the same thing as before. So here top to bottom. Okay, for I is equal to, for int I is equal to top, I less than or equal to bottom, and I plus plus. In this case, I will have to again add it to the output. Spiral order dot add matrix of, here what's the value of top? So top value is assigned to I and it keeps varying. So let's call the row as I, and what's the column? Column value here is all the values in this right. So this should be right value. So I and right. Okay. So once this one is done, once we traverse through all the right elements, sorry, top to bottom here on the right. So now we should go right to left. But the rightmost element is already printed when we came from top to bottom. So what should we do? We should decrement rightmost element by 1 so that we can start printing from here. So in the same way incremented the top, we should decrement the right here. Okay, so now we can start from 11 to 11, 10, 9. We can start from like this. So once we are done with this, we can go from, again this one is um, right to left. Okay, so here for int I is equal to right, I greater than or equal to 0. I thought of going to 0. Should I go with 0 or left? So left value is 0 only. I think I should go with left for now instead of 0. That would be generic. So left, and then I minus minus. In this case, I'm going in the reverse direction. So I minus minus. So now what I need to print? Spiral order dot add matrix of it should be okay. So it is the bottom row that we are printing. So the bottom would be fixed. So I can just print it as bottom, and then the right index will become high. That is varying from right to left. So that is done. Once I go from right to left here, I need to print from bottom to top. But the bottom value, this 9 is already printed. So I should decrement bottom by 1. Bottom minus minus. And then I should go from bottom to top in the same way. Let's copy this and paste this. Bottom to top. I is equal to bottom. I greater than or equal to top. And I minus minus. Spiral order dot add matrix of. In this one, left will be fixed. But we will go from bottom to top. So the row will vary. Row will go from bottom to top. So I'll enter that as I, bottom to top, and then the left, it is in the leftmost row. So I'll keep this as constant left, and then I need to increment the left also. So the next we should move to the next one here. Like I printed 9.5 here. Okay, and I didn't go to the top. Okay, because I kept it as greater than or equal to top. So top value was decremented to this one. So I just went till 5. Top value was decremented here, right? Or incremented here. Top plus plus we did. So top value became 1. So I just went till here. And then now I have to go from left to right. Left value, I just increment. I need to increment. Otherwise, I have a risk of printing this 5 again. So I will increment it here, left plus plus. Okay. So here, after doing this, it will go and it will print 5, 6, 7. So this should work for this value. 5, 6, 7, left to right. Okay. Again, left to right here. Left to right, 5, 6, 7 will be printed. And I'll do top plus plus. So top would become 2 now. And here, top to bottom, I is equal to top, top less than or equal to bottom. Bottom value is, I already did bottom minus minus. So there is nothing like that. And then I'll do right minus minus here. Let's try running this. I feel that there is something missing here, but we can add it. We can see, we can troubleshoot and add it. So let's run for the base cases. Okay, return, I haven't returned the output. So let's return this. Return the output. Okay, index 3 out of bounds for length 3. So, and it is in the line number 21. Okay, when did we try to get to index I or index right? So, Okay, here one thing, matrix dot 0 of length minus 1 it should, not length. So that's how why it is still giving I dot right. Okay, yeah, it's still giving the same error. So we did left to right, and then I is equal to top and I less than or equal to bottom. Why am I getting this error? So okay, let's see this example. We followed the other example. Let's follow the square here. So 1, 2, 3. We followed 1, 2, 3. So top. Okay, we can just trace this one. Trace all the values here. Okay, let's see what's the value of left. Left is equal to 0, and right would be is equal to 2, and then top will be equal to 0, bottom will be equal to 2. Yeah, length minus 1, so that should be equal to 2. And then our output is nothing as of now. Yeah, let's trace our code. So left less than or equal to right, true. Top less than or equal to bottom, that's true. Yeah, that's those both are true. And then if I is equal to left, I less than or equal to right, that's true. Okay, we are coming here. Spiral dot add matrix of top comma I. So I keep go from left to right, and then I'll keep adding here. Less than or equal to right. Yeah, it is minus 1, so I'm going. Okay, so to the output I just added 1 comma 2 comma 3, and here I is equal to top. I incremented the top by 1, so top became 1, and I is equal to top, I less than or equal to bottom, I plus plus. Okay, so I is equal to top. Yeah, I less than or equal to bottom, I plus plus. Got it. And then I'll add all those elements. Matrix of I comma right. Right is matrix dot length minus 1. So yeah, 2. So 2 comma, I mean I comma 2. So that should give me 369 values, or 69 values, because I started from, I incremented the top and I started from the value 1. So that should be 6 comma 9. And then what do? I decrement the right by 1. So the right value was 2. I'll decrement it to 1. Okay, got it. So now I'll go again. I is equal to right, I greater than or equal to left, and I minus minus. Left value is 0. So I go from right. I is equal to right means I is equal to 1. So 1 is here. So from this coordinate, I will go to the left and print all those values. So it should be 8, 7. So I printed 8, 7. And then what did I do? Bottom minus minus. Bottom minus minus. So bottom was 2. Bottom will become 1. And then I should traverse bottom to top. So bottom value is 1 now. I is equal to bottom. I greater than or equal to top. Top value is 1. So bottom value is 1 and top value is 1. So I is equal to bottom. I greater than or equal to top. So I'll iterate it once. And I'll just print that bottom value. Spiral dot add matrix of I dot left. So I dot left means just this value 4. I'll print 4 in the output. So I'm adding 4 here. So once that is done, let's see next thing. Yeah, next thing again, I'll get back in the loop. Is left is less than or equal to right? Okay, I need to do left plus plus. Left plus plus I did and I changed it to 1. Is left is less than or equal to right? Yes, that satisfies. And is top is less than or equal to bottom? Yes, top is less than or equal to bottom. So I will get inside the loop again, and I is equal to left, I less than or equal to right, that satisfies I plus plus, and spiral order of matrix of top and I. Top value is 1 and I value is I'm in left, so that was 1. So matrix of 1 1, I'll print 5. So I added 5 in the output. Now top plus plus, I made a task top plus plus. Top plus plus means it will be 2. Top will be 2. Here for I is equal to top, I less than or equal to bottom, I plus plus. I is equal to top, I less than or equal to bottom. I is not less than or equal to bottom, so there's no value here, and this fails. And I will do right minus minus. I won't print anything. I'll do right minus minus. The right value is 0 now. And again I'll come here. I is equal to right, I less greater than or equal to left, I minus minus, I is equal to right, I is equal to right 0, I greater than or equal to left. There, no, it's not. So nothing is printed here. I'll do bottom minus minus. Bottom minus minus will become make bottom 0. And okay, again I'll check. Bottom greater than or equal to top. Bottom, no, it's not greater than or equal to top. So I'll just do left plus plus. Okay, so now left is less than or equal to right. Left is less than or equal to right. And then top is less than or equal to bottom. Both condition doesn't satisfy. We will just come out and print the spiral order. That looks right for this matrix, I think, but I'm not sure why it is saying index 3 out of bounds for length 3. Let's try executing with more data here. Let's print top. Okay, left, right, top, bottom. Left plus right plus top plus bottom. So this might do integer addition also. So let's add something in between. Okay, let's print this and see. So here 0203 is printed. 0203 is printed when we just enter this one. So bottom value is 1 2 3 4 5 6 7 8 9. Let's execute for this one. 0203 is printed. why is this taking as 3 for matrix of 0 dot length minus 1? This one has been taken as 3. Okay, right is equal to, this is the row number, left is the row number, and this one is the column number. Okay, I might have reversed these two. Yeah, so right is last element in the first row. Yeah, so in the first row itself, what is the length of that? That defines the right. And bottom is total number of rows basically. So total number of rows gives the bottom, and right is what's the length of the first row. Okay, so this is the length of the first row, and this is the total number of rows minus 1. Okay, this should help us make progress. Yeah, this helped us make progress. So yeah, so here this was expected, this error 0302 initial value, and then it became 1211. But the problem is I have printed an extra 6 here, like 6 and 7. So you can compare both the outputs. The expected output is 1, 2, 3, 4 up to 7. But here I have printed the same numbers in the same order, but I have printed an extra 6 here. So after 5, like I came spiraling like this, and then I printed this 6 again. So this 6 is again, which is doing top to bottom, I guess. Probably. So no, it's not top to bottom. It should be, when have I printed this? I think I need some guardrails about when to execute these loops. And based on that, I think I can resolve this issue. So how to do that? Let's see. Now I'm kind of tracing the same thing. This is bottom to top, right to left, and this is top to bottom. Okay. So here we can see view more. Okay, I went from left to right once, left to right 4 times. Okay, so that is cool. And then top to bottom twice. Like I printed 4 elements here, and then I printed 2 elements. So if we look into this, which example are we seeing? Use case 2. So yeah, so this means I printed 4 elements, 1, 2, 3, 4. Okay, and then I printed 2 elements, 8, 12, top to bottom, top to bottom. So that gave me 8, 12. And then right to left, and I printed 3 elements, 11, 10, and 9, these 3. And then bottom to top, I printed 9 and 5. No, just 5. That's one element. And then I did left to right again. Left to right, I printed 2 elements here. 6 and 7. Okay, and then I have printed 6 again while doing right to left. I have printed 6 again while doing right to left. Why? So that is the issue. Why I have printed while going right to left, and that should have been avoided. So here you can see right to left. So I is equal to right, I greater than or equal to left. I think I is equal to left at that point. Because I increment the left here, I still haven't incremented the left in this round. So I just checked if I is greater than or equal to left, and then I just executed it. So what I can do is, in this case, I already, should I check for left and right values? That is kind of what my initial thinking was. But another thinking is, here, rather than I less than or equal to this one, like once I do this thing, it's like I covered from left to right, and then I incremented the top. Once I incremented the top, so top became, like, top was already 8 and top became 12 here. I mean, this third row, top was already 1, it became 2. And then my bottom was 2, and I made it as 1 in the first iteration only. So bottom is less than top. So I think I can check for that before executing this right to left. If top is less than or equal to bottom. So if that still holds good, then let's execute this. Otherwise, let's not. Okay. Now I check for top to bottom. I think in the same way, we should check for this one also. Here, I'm going from bottom to top, but we need to check if left is less than or equal to right before doing this. So let's see. Bad copy. Yeah. Left is less than or equal to right. And let's close that. Okay. So this is done now, bottom to top. Okay. So now we should not have printed this additional 6. We should not get this additional 6. Okay. Am I sharing it right? Okay, let's do view less. Okay. We have this additional 6. We should not print this. Okay, we haven't printed that additional 6 because we checked that, we made a check that, okay, bottom was less than top when we are going from right to left. So yeah, now we made sure that the output is intact. So we can try submitting it, but before submitting, we can remove this commented code that I used to explain, and then we can take out this print statements as well that we used for troubleshooting. Yeah, because that could impact some runtime. So yeah, rest everything looks good to me. Got it. We can submit this. Oh, it's taking a long time. Possibility that there is no, it works. It's 2.33% because why does it take so much time? Are there any catches? Okay, I have a print statement here again. So let's remove this one also. Okay, yeah, I removed that print statement. So now the runtime is good. So yeah, this is awesome. Yeah, I'm happy that we got to this solution. Let's see. Let's look into the chat section now. Sadam had a question. Later, can you explain the problem? Longest palindromic substring again. Just a brief, maybe 5-minute walkthrough. I'm a little bit of lost of why we need odd substring and even substring. Okay, sure, Sadam. Shall I explain it now? I wanted to take a break, so before taking the break, I can quickly explain this and then we can start with a fresh problem after the break. How does that sound? I wish we had some real time chat. Okay, awesome, awesome, Sadam. So yeah, we can think of some tools. Like, feel free to suggest if there is a way you can communicate with me in real time so that we can address back and forth, and keep it make it more useful for everybody, for me and for you guys and everyone. So let's see. So what is it? Longest palindromic substring. So let's look into that. I think we had solved that yesterday. So longest palindromic substring. Okay, here longest palindromic substring, lead, lead code number 5, and it's a lead code medium problem. Let's look into the question again. Given a string S, return the longest palindromic string in S. So in this one, a string is given as BABAD. Okay, yeah. This one we learned yesterday, right? How to solve it. So the approach is plain and simple. Let's see why we need odd and even length. That's specifically your question. So the approach that we are following is, if string dot length is 0, then return empty string. Okay. So these things are fine. So let me get to the whiteboard and see, and try to explain it there. So it will be much more clearer that way. So let me open that. And this is the problem, longest palindromic substring. Okay. Let me copy over. I'm sharing the whiteboard now. Okay. And let's take an example string as race car that we had seen yesterday. So the way we are approaching these problems, or another example can be something like, we can look into that later. So in this one, let's do that also. So another thing can be, so okay, this doesn't have a meaning, like cap back, basically cap back. So uh, this is a this is another palindrome, right? Cap back. So we can see from the beginning, from end. So this is a what is the length of this race car? So the length of this one is 7. The length of this string is 6. So in even length palindrome, we see there is no exact middle element. So whatever the middle element, either this one or this one, those two should be equal. And we will expand from there to around it. Like, okay, A is equal. So now we expanded. Okay, this could be a palindrome also. And then again we check CC, those two are equal. And then we expanded and declared that whole thing was a palindrome. So the longest palindrome possible was of length 6. In the same way here, when we like, I'll explain how we are solving in the problem only. We come to R first. R is the index 1 or index 0. So I'll see if there is anything uh, that we can expand from the center and try to create a bigger palindrome. So in this one, there's no way that we can expand from center because there's no I minus 1. So the maximum palindrome starting from, like, when we check for this one as center is of length 1. And when we check for A as center, let's see. And then I'll pass this as this one, like pass the R is not equal to C. The things around it is not equal to C. If A is center and if it's a odd length palindrome. What if this can be an even length palindrome like this? Like, let's say if this was also A and this was like a RAR car. So here if this is A, so this thing can be a palindrome, right? Like A can be a center of palindrome if this was the case. But we won't consider that if we just consider the odd length palindrome. We need to consider the even length palindrome also for that case. So, okay, A can be center in one way. Okay, R is not equal to A. We cannot just discard it there. We should send A and A plus 1 both. we should consider this one. Okay, these two are equal. First, we will check that one. These two are equal, and then we can expand around this one also. Okay, now these two are also equal. So this would make a palindrome. So the maximum length palindrome is 4 here. And then I'll move to this A. This A, I'll check for odd length palindrome as this one as the center. This is not equal to this, so that is discarded when we expand it around center. I'm checking for even length palindrome by considering A and R. These two itself is not equal, so that's not a even length palindrome also. So nothing. So for R, again, A is not equal to C, nothing. And R and C for even length palindrome, these two itself is not equal, so discarded. And for C, C is like R and A are not like not equal, so it's not a odd length palindrome. And C and A, those two itself are not equal, so it cannot make an even length palindrome also. Same thing for A and same thing for R. So the maximum palindrome that we can get is RAAR, which is an even length palindrome. That's why we have to consider both odd length and even length string in this case. So just let me know if that is clear why we took odd length and even length palindrome. We can go through the code if you understood that part. Okay. Okay. Awesome. Okay. Now the concept is understood. Let's go through the code. How we are solving that. In order to keep track of the longest palindrome here, like we are expanding around the center, and we are keeping track of what's the longest length palindrome, what is the maximum length of it, and what is the starting character of it. If we know that, if we know which one is the starting character and what is the length of it, then we can know what is the longest word, right? Starting from this index, longest start, what is the length? Like if we say that, okay, for race car, for example, like something like race car, if the longest start is 0, like longest start is 0 and max length is 7, we know, okay, it starts from 0 and max length is 7, the entire word is the palindrome. So I'll return race car from 0. And let's say that rare cab or something that we saw in that example, rare car, yeah. For this one, maximum length palindrome is this RAAR, right? So that is the maximum length palindrome. So longest start will be 0 again, but the max length will be 4. So we will know from 0 we should return 4 characters. So that we will return rar only. So we can see this one as an example with this implementation. We will see that. Let's remove this for now. And while running, okay, I hope the outputs are visible. Okay, okay. So you see, it is just 4 characters. So how did this work? So here I took the longest start as 0 and max length as 0 to start with, and I is equal to 0. So starting from first letter, as I know, as I explained in the whiteboard back there, I'm checking for the odd length palindrome while keeping 0th index as the center. I'm trying to expand from center. So if we had considered that, again, let's take the same thing. Okay. So now we are taking this 0th index or 0th character, and we are trying to expand around it. S of I comma I. For odd length, I is the same thing. So that is 0. So, and I am expanding around the character. It checks for, okay, left is greater than or equal to 0, right is less than or equal to string length minus 1. That is like basic routine check to see that, okay, the index is within the limit. And then I'm checking if s dot character at left is equal to s dot character of right. So now since I'm passing the same character, this will satisfy the first instance. And then I'm doing left minus minus, right plus plus. Once I do that, okay, my left will become here, in this case, 0th character. My left will become minus 1 and right will become plus 1. So left minus minus, so left will become minus 1 and right will become plus 1. So I am returning right, which is 1. Minus of minus 1, which is 2. Minus of minus 1 is 1 minus of minus 1 will become 2. 2 minus 1, I am returning it as 1. So with r as with index as 0, the maximum length of odd length palindrome is only 1. Uh, and let's check for the even length palindrome. And I am sending I and I plus 1 here. I is 0 and I plus 1 is 1. So this I am sending these two parts as of now. Okay. And here first step only, s dot caret left is not equal to s dot caret right. So this won't even execute. So right minus left minus 1 means right was 1, left was 0. So 1 minus 0, 0. Sorry, 1 minus 0, 1. 1 minus 1, 0. So two length uh, or even length palindrome is not possible with this thing as the center. So now I'm moving to index 1 and I'll do the same check. For odd length palindrome, this A would not return odd length palindrome. It will be max length will be 1 only because R is not equal to A, which will fail. For even length palindrome, now I'm sending I is equal to 1 and then I plus 1 is equal to 2. So I'm sending 1 and 2 here. So now in this case, okay, s dot caret left is equal to s dot caret I, caret right. So A is equal to A. So left minus minus and right plus plus. So left became 0 and right became 3. So left became 0 and right became 3. And then I came back to the loop again. And then s dot caret 0 is equal to s dot caret 3. Yes, that is also true. R is equal to R. And again I'll do left minus minus, right plus plus. So right became 4 and left became minus 1. So and like since it is minus 1, we will come out of the loop. Now 4 minus 1 minus of minus 1. 4 minus of minus 1 means 5. 5 minus 1, 4. That is the maximum length of the even length palindrome starting from A as the center. So that's how we keep computing for each character, like what is the maximum palindrome that we can build by keeping this as the center. One thing is for the odd length, and the other thing is for the even length. That's about it. Hope this one is clear now. And then yeah, to just for the sake of completion, if current max is greater than max length, so I'm just replacing whatever the current max, if that is greater than the max length character, I'm replacing the max length character. And here for the longest chart, I'm checking here. Okay, how to get this longest chart value. So now I know the max length palindrome from this I as the center. So I'm checking like if I as the center and if I know the maximum length, I'm just doing maximum length minus 1 divided by 2. That would give me, and I'm subtracting it from this center. So that would be the starting character of this palindrome. And I'm returning that substring with the longest start and longest start plus max length as the ending index. That should be, that's it. Yeah, let's take a break now and we can meet back in like probably 5 minutes. That should be good enough. Yeah, hope it's useful. So drop a feedback about how it is going, if it's being useful or not, or if I have to change anything. So just unmuted. So is everyone back now? Okay, we are done with. I think I don't know if we entered the last problem into that link that I've been sharing. Eighth problem we haven't added. Eighth problem was climbing stairs, and then we did spiral matrix, and then we revisited this. So let's add this one to the list. Okay, that one is added. So let's add the spiral matrix, getting the corresponding link. Okay, so let me refresh that. Okay, it's going good. 9 problems. Awesome. Okay, let's go. So this one is done anyway. Spiral order. So next thing is spiral matrix is done. Meeting rooms 2. Meeting rooms 2. Okay, there is solution. Let me remove this. Okay, so let's read the. Okay, LeetCode number 253. Meeting rooms 2. I'm unmuted. Okay. LeetCode number 253. Meeting rooms 2. And it's a LeetCode medium problem. Let's read the question. Given an array of meeting time intervals where intervals of I is equal to start of I and end of I, the same way, return the minimum number of conference rooms required. Minimum number of conference rooms required. That means I should minimum number of conferences rooms required. So I need to figure out at a time how many meetings can happen. So I mean, if there are no overlapping meetings, then I think we can just manage with one conference room, right? Like we can just use the conference room one meeting after another. But if there are meetings scheduled at the same time, there are multiple meetings scheduled at the same time or at overlapping time. Like it doesn't have to be like from 0 to 30 only. If there is another meeting from 5 to 10, let's say here only in this example, this is 0 to 30, and they will have the conference room one occupied, let's say. When we need to conduct a meeting or run a meeting between 5 to 10, we need another meeting room because there is a meeting going on or long running meeting going on in this conference room. And then 15 to 20, again, this meeting room is going on, but this doesn't coincide with this meeting room. So if we have two meeting rooms, this would have occupied the first one, and we will have this meeting room. Once they are done with their meeting, these people can run their meeting in the same room. So we need at most two rooms. Here you can see meeting runs from 7 to 10, and then meeting runs from 2 to 4. So both are not overlapping. We can just manage with one meeting room. So how to solve this? In these kind of things, first thing is we need to sort it based on the meeting's start time in order to figure out the overlaps. That's the constant. After that, what we can do is we can keep going through each of the meeting schedules, and then if there are no overlaps, basically I need to check what is there in the, like we can take a kind of priority queue and then add this to a priority queue, and then once this is in the priority queue, next meeting will come and see this has a overlapping time with this one. If yes, then I think I will just add this to the priority queue as well if this has overlapping time. And then here I'll see if this one has a overlapping time with this. If yes, then I'll add that also into the priority queue. And I'll return the size of the priority queue. And okay, return the size based on the size of the priority queue at every interval. Whenever I add this, whenever I am adding this, I can determine how many meeting rooms are needed. So in this case, the catch is I'm thinking when I come to uh, 15 and 20, when I'll remove this 510, at which point I'll remove this 510 meeting from the priority queue. So first thing is, let's go get to the whiteboard here. Okay, meeting rooms too. Okay, and then let's copy these things. Okay, so if we take a priority queue here, as I said, first thing is that we need to sort it. In this case, sort it based on the start time. So in this one, it is already sorted. So first step is sort the input based on start time. So second step is initiate a priority queue or initialize a priority queue, whether it should be a min or max. So here, let's see, I will determine if it's a min or a max now. I added 0 to 30, this 0 to 30 into the priority queue. So let's say this as one of the meeting event. Okay, and then this 5 to 10 came. I'm checking this 5 with this 0 to 30, and then when this gets started, this is still not over. Like I'm checking this end time with the start time, so it is overlapping time. So I'll add this 5 to 10 also into the priority queue. 5 to 10 also into the priority queue, and then this 15 to 20 came. I need to check if this meeting got over or if there is something. So I don't think this can be at the top 0 to 30 because that could mask this meeting. So let's keep this one at the top. Okay, let's keep this one at the top, and I have to compare this 15 to 20, this meeting with the top. This is not overlapping. If this is not overlapping, I can just remove this one from the heap, and then I can check the next one. Okay, this one is still overlapping, and then I'll add 15 to 20 into the heap once I remove that. So this will be at the top. If I have more elements, I'll keep comparing with the top. So now the top is the minimum or the earliest finishing meeting, the meeting which will gets over a little early. So in that case, what can I do? I can initialize the min heap for that order, min heap based on meeting end time. So this is what is needed. Min heap based on meeting end time. So to iterate the problem again, okay, now we have clarity about we need a min heap. So I'm just iterating through each of this meeting, and first thing is 0 to 30 came. I don't have anything to compare with. I'll just add it to the priority queue, and this will be at the top of the priority queue as well. Like when I need to return min, this will be returned. And then 5 to 10 came. It will check the min element here or the top element here. So the end time is less than or end time is greater than the start time of this meeting. So I'll add that also into the meeting, and I will keep another variable to check max rooms needed. So when I added this one, the max room is needed was 1. I initially initialized it to 0. When I added this 0 to 30, I made it as 1. When I added this 5 to 10, let's say, that will be added as, that will be the min element. So that will go to the top of this. So 510. Now I'll update, like I'll check the simultaneously running meeting. These are like, this signifies these meetings are running simultaneously. are at the same time. So I'll update the meeting rooms needed to 2. Now I came across the next meeting instance 15 to 20. When this 15 to 20 came, it checked with the top element. Okay, 5 to 10. So 10 is already over. I'm at 15 now. So 10 is already over, or that meeting is over. So I just removed it from the priority queue. And then I'm checking it from the top of the stack again. Okay, this will run until 30. And the time is 15 now. So I will start it before it runs. So I will start this meeting 15 to 30. Once I add this to the priority queue, I need to check again. Max rooms needed is the size of the priority queue. Still it is 2 because we removed the other meeting and we are adding this meeting. So max rooms needed is 2. Let's say if there was another meeting instance here, which runs from, let's say, 19 to 25. Okay. If there was another meeting, then I would have checked the top with the top again. This is 15 to 20. Okay, this is 15 to 20. So I checked with the top again. Okay, top meeting will, or the minimum or the earliest finishing meeting will run till 20th minute, and this is 19th minute. I need to start now before it's finished. So it will decide and it won't remove anything, but it will add on top of this one, 19 to 25. Okay, now I'll check what are the simultaneously or the uh, what are the meetings that are running together, and I'll update it as the priority queue size, which is 3. And then, yeah, I'm done with all the iterating through all the meetings. So maximum rooms needed is, or the minimum rooms needed is 3. This is the minimum rooms needed to run all the meetings without any conflict. Okay, let's try to code the same thing. So we need a priority queue. We need to sort the input based on our start time. Let's get to the lead code screen. Hope this is understood. This isn't as easy as the other problems. Um, let's see. First thing is, okay, array of intervals is given. So I'll just add a comment. Sort the input based on start time. Okay, so arrays dot sort, and then you need to sort the intervals. And the criteria is, let's say if interval 1 and interval 2 is given, how do we determine? Integer dot compare interval. Okay, I think I can just in the next line. Yeah, integer dot compare interval 1 of 0. 0 is the start. I'm taking 0 because 0 is the start time. And then of interval 2 of 0. So I'm just comparing the start time of both the intervals and I'm sorting it based on that. Now let's say what is the default in the priority queue? Initialize a min heap based on the end time, not based on the start time, because we need the ending time, like which one will end first, as we saw in the whiteboard. So here I'm checking here, initialize the min heap based on the end time. By default, whenever we initialize, if we don't define anything, it will be based on end time. So priority queue of, what is it? It is integer. That is one of the individual interval basically. So min heap, uh, min heap earliest ending basically, or yeah, whichever ends early, that would be the minimum value there. So new priority queue, and I need to pass the comparator here. Comparator will be, again, I'll take the similar case here. Interval 1 and interval 2 are given. I'm comparing it based on the end time, not based on the start time. So let's copy the same thing. End time is of 1. Okay. So this should give the priority queue, like, for which by default it is min heap. So I'm just passing the comparator in the same format. I'm asking it to compare the end time instead of the start time. That's all I'm prompting here. So that is done. So now once I initialize the priority queue, I need to keep iterating through these intervals and then see what's the uh, maximum or the minimum number of rooms needed. So int min rooms needed is equal to 0, min rooms required. That's the wording used in the question. So I replace it with min rooms required. So int I is equal to 0, I less than intervals dot length. Okay, I'm iterating through that. And then now I have to check here, like I need to check in the priority queue. Like if there is a, let's go to the whiteboard. Another thing is like, let's say another exam, if there was another meeting after this, let's say that start from 40 to ends at 50. If there was this meeting, then after this state, okay, what is at the top here? So the top would be, actually top was supposed to be this one. This is the min, right? Minimum element here, which will end the earliest. So I'm comparing the, like my min heap will be determined based on the end time. So end time minimum is this one. So now 40 to 50 comes and it will check the end time of this. Okay, the start time of this meeting is greater than the end time of this. So this doesn't overlap. So I can just remove it from the min heap. And I'll do the same thing with the next element. Now this is the minimum ending time. And then start time is way ahead. So I can just remove this one also. And I'll compare with this one. So this one I can remove this one also. And I will just add the current meeting, 40 to 50. So that means I came back here just to explain that, okay, I need to keep removing from the priority queue until there is no overlap. So first thing is, while min heap is not equal to null or min heap is not empty, min heap is not empty, and min heap dot peak. So I'm looking at the peak value of that, and I should look at the end time of the peak value. So peak of 1, if that is, while that is less than the current value. Current value is, let's keep the current value as current interval here. Current interval is equal to intervals of I. So that's the current interval. So if it is less than current interval start time, which is this one, if the peak end time is less than current interval start time, then that is, that doesn't overlap. All I can do is I can just remove it from the min heap dot poll. So as long as that doesn't overlap, I'll keep removing it. And then what I'll do is, at the end, I'll add the current meeting to the min heap, current interval to the min heap. Min heap dot add, min heap dot offer, I think, current interval. And min heap would sort it by itself based on the minimum ending time of the meeting. So this should give this one. And then minimum rooms required is equal to math dot maximum value of maximum value of the minimum rooms required until now, and the size of the min heap. Basically, size of the min heap signifies, as we said, the concurrently running meetings. All the meetings running concurrently would be in the priority queue. So min heap dot size would signify the concurrent meetings, and that many number of meeting rooms are required for us. Okay, once this is done, we can return the min rooms required. Let's see if there is anything here. We initialized the priority queue based on the end time of the min heap, end time of the interval, and then iterating through each interval and comparing here with the peak of the min heap end time to the current interval start time. If it is satisfies, then I'm pulling it out of the heap, and then I'm adding the current interval to the heap, and minimum rooms required is okay. Yeah, this looks good at least from the glance. Okay, other than the syntax error. Okay, this looks good for the basic test cases. 0 to 35, 10, this is what we compared 7, 10. It returned 1 for this. Let's submit this and check. Okay, there is some other scenarios that we might not have handled. So 13, 15 and 1 and 13. So for this one, output needed is 1, but I have returned it as 2. So this one starts, this 13, 15 starts after this one ends. So this is kind of like yesterday we considered it as overlapping in another problem. So I considered it as overlapping today also. So what we can do is here, if it ends at the same time, I can pull it out. Basically, if min heap dot peak of 1 is less than, I'm just checking if it is less than the current interval. If it is less than or equal to also, then also I need to pull it out. This means, so I added that case, test case, and let's run this locally first. Okay, now it succeeds. Let's submit this. So it's always wise to get it clarified beforehand with the interviewer. I didn't do it this time. Last time I think I did that, but this time I didn't. So yeah, I think this looks good. Yeah. So let's move on to the next problem now. This one is using priority queue. We had recently looked into the priority queue concepts and min heap concepts. If you want more details into that, just refer the other other videos that I have made where I explain priority queue and how it works in detail, and I have explained the implementation of the priority queue as. So I can post the link for that if you want, or you have the link for my channel. You can just look into search for priority queues there, or you can search for heap there. So let's see how's it going on for everybody. Start of the start of the weekend. Let's see. Um, this one is done. I'll mark this as done. And next question is merge case sorted list. Let's add it back. Okay, this is a hard problem, but we have seen this one before, I guess. And this is not hard. I have made a video about this one also, this problem. So this should be easily solvable, at least for me. And it's in general, I don't think it qualifies to be in the hard problems, LeetCode hard problems, classified as LeetCode hard. It is relatively easy compared to a lot of problems that we have seen. Okay, so what was I doing? Yeah, I needed to enter it into our journal where we are keeping the journal. Okay, in our journal we can enter, how should we segregate with respect to the date as well? So the date for today is 15. So 01 15, or it is 02 15 2025. arrays. Okay. We have kind of solved two problems, but we repeated one problem from yesterday which did not have any voice. So we solved three problems effectively in this stream. So let's aim for more now. Merge case sorted list. Okay, merge case sorted list, lead code number 23, and it's a lead code hard problem. Let's read the question. You are given an array of k linked lists. That means list of linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So for this one, I think there's a better explanation in a standalone video. You can refer to that. But here, let's go over this quickly. In the question, there are lists of linked lists given. So individual lists are the linked lists here. So 145, 134, and 26. We need to merge those three in the ascending order and create a combined linked list and return the head of the linked list. So 1 1 you can see, and ascending order in terms of value. So the linked list node is defined like this here. They have given the definition. This is not written by me. They have given the definition already. It will have a value. It will have a next, and these are just utility constructor method to create a list node. So now how do we go about this? So the simple approach we just discussed about priority queue. So here we don't know this 4 5 and we don't know this 3 4 or 6. We just know the value of the current node in a linked list, or we just know the head of the linked list here. For each of those we know the head of the linked list, and we will add the head node into the priority queue. So we will have only three elements in the priority queue. So if there are like four arrays are given or four linked lists are given, then we would have four. Basically, n elements, like the number of nodes in the priority queue or the heap depends on the number of the linked list given. Here three is given, so we will have only three elements. We won't add individual nodes into the priority queue. We will just add the head of the linked list. So here now, as of now, for all reasons, we just know the head of the linked list node, which is value 1, 1, and 6. Whatever comes in future, when we do 1 dot next, we don't know that. Since it is represented here, we can see this one. But if they had given just the reference of the linked list like this one, without giving this example, we wouldn't, here we don't know the value of this one in any way, unless we traverse through that linked list. So let's see, as I said, we will initialize a priority queue, and how the priority queue should be ordered. Priority queue should be ordered based on the minimum value of the current head. So if the current head value is 1, 1, and 2, we should print one value with 1, 1 first. Like print means we should add that to the output first, and then we should go to the 3, 4, and rest. So we should initialize the min heap based on the value of the list node. So let's add this one, priority queue, which is of type list node, and it's a min heap is equal to min heap is by default. By default, a heap is a min heap. We don't have to do any reverse order or anything. But we need to define the criteria here. Priority queue. Okay, so how do we define it? So we saw it multiple times. So node 1, let's say node 2 are given. If node 1 and node 2 are given, we are deciding based on integer.compare. When it's an integer, it's easy. You don't have to do a lot of anything. So node 1.val, comma, node 2.val. So we are comparing that, and that will take care of sorting it in the min heap in the order desired for the min heap. but we are just giving it which value to be compared. Okay, so now the priority queue is defined. Now another thing is we need to define the output. For the output, let's define a dummy head. Dummy head is equal to new list node, and we can provide any arbitrary value, or it can be empty also. Yeah, we can provide any arbitrary value. Let's say this one was 0. We can just leave it as it is also, I think. And then we need to start tracing from there. And this is a list of, okay, this is not list node. This is a list node of dummy head. And then let's initialize another variable to keep track of the moving pointer. Like as of now, we are in the head. We need to return the head at the end as form of the output. But we need to keep traversing also while adding elements in the linked list. So in the linked list, we do not have a previous pointer, so we cannot come back and return the head later. So let's copy the reference to another variable as well called as current node is equal to new that sorry, that would be dummy head only. So I'm initializing another node. So now what should we do? First thing is we should be adding all these three elements or all these initially provided lists head of these lists into the priority queue. So min heap dot add. So let's iterate through each of those. For list node in the list. So lists of linked lists are given. So I have taken that list min heap dot offer the node. I have added it in the priority queue. So that will be added into the priority queue in the order that we need. So it is a min heap also that we know. So let's add this line also here. They are kind of related. I initialize the min heap and then added that, and then I initialize the dummy node and the dummy head. And then while priority queue is not equal to or min heap is not equal to is not empty, we can keep going. Min heap dot is not empty. We can keep going and adding it to the output. So here now we need to take the first element, which is 1 or from this node. Like okay, so now we have the, let's say we have the PQ priority queue has 3 elements, which will be okay. In the same way, it will have 3 elements: 1 4 5 1 3 4 and 2 6, and it will be ordered somewhere similar. I haven't defined what if the first one is equal. Would it break it? So it could be 1 4 5 or 1 3 4 in the beginning. Let's assume that it's 1 4 5. So this is the criteria. Okay. Now I'm going through that min heap until the min heap is empty. So now I'll try to get one element out of the min heap. So if I get one of the node out of the min heap, this node, min node or current minimum node, let's say um, let's just take it as node. Node is equal to min heap dot poll. So I took the minimum element out of the min heap. Once I take that out, what should I do? I should attach it to the output. So how do I attach it to the output? So for tracking that, I have this current node. So what I'll do is current node dot next is equal to whatever the node I got here. And then what I'll do, I'll increment the current node to point to its next node, so that I should be able to keep adding the chain of linked list or forming the chain of linked list. So current node is equal to current node dot next. So now it became, I removed this one from the min heap already, and this became node is equal to this one, and my current node was pointing to 0 in the beginning. now I added this one also into the current node. So this 145, and now what will happen? So this 1450 and 145 is given. So it will be like this, logically speaking. It will be like this currently, 0 and 145. The linked list will look like this. Okay, like this. And now what I should do? I should try to add this 4 5 back to the priority queue, not the one, but from the next element. So in order to do that, let's add this one, min heap dot add. I made it as current node is equal to current node dot next, and then now I'll do current, like current node is now pointing to 1, so current node dot next, the next one, which is 4, I'll add that back to the min heap. Let's use offer for consistency instead of add. Okay, but another criteria I missed was, what if there is a null after 1? I don't want to add null to the priority queue. I just want to add if there is some value. If that's the case, let's do this. If let's do a valid, like let's do a validation here. If current node dot next not equal to null, then only add it back to the min heap, otherwise don't. Okay, so that is done. So current node also I have incremented and everything is done now. So once I do this one, it will add back this 4 5 into the loop, but it won't cut it from 1 yet. So it will add the 4 5 into the min heap. So that will go at the end in the min heap, because in the min heap the top will be minimum value. So 4 5 will be here. Okay, so now it is clear. So now again it came, again we came here to the same thing, and we are checking here what's the min node here. Get me the min node. It gives back 134. So min node is, or the node is 134 at this point. Okay, so this will be replaced by 134. Node is, when I query from the min heap, node will become 134. And then current node dot next is equal to node. Current node is pointing to 0 1. As of now, it is pointing to 1. So current node is pointing to actually 1. I think I can just remove this. Dummy node is like this. Dummy node is pointing like this. It has 0 and 145 like this. Current node is just 145. So now what did I do? Current node is 1. So current node dot next is equal to node. Current node dot next is equal to this. It will become this 134. So I'll take this one, and it will be this 134. Okay, it will be this 134, and the same thing will be the case of this one also, because dummy node dot next is current, so it is modifying this list only. Both are referring to the same one. So one, but it is pointing to the next node in the same list. So current node is equal to current node dot next. So now current node will point from this one to this one. So I can just remove this. So it is pointing to this one. And then now if current node dot next is not equal to null, current node dot next is not equal to null, I'll add it back to the min heap. So I had popped this out already. So now I need to add this to the min heap. When I add it to the min heap, it will be added here as 3 comma. It won't be added here actually. It will pop up to the top later, but we can just represent it in the sorted order now. Min heap won't be in the sorted order, but it will always provide the min value at the top. That is guaranteed. So yeah, this is done. Min heap dot offer. So in the same way, it will continue. It will keep popping the minimum value. Now next thing is it will pop the 2, and then it will replace this by 2 here, and then this will be again 2 6. So yeah, in the same way, like now I pop 2 6. Let's say just to run this one, node will be 2 6, and then it will be removed from here. And then first thing is it will add it to the current node dot next. Current node dot next will become 2 6, and current node is equal to current node dot next. So current node will start pointing. So 2 6 will be replaced here also. 6, and then current node will point to the next element here, 2 6. And yeah, what else? If current node dot next not equal to null, so add it back to the heap. So when I add it back to the heap, I'll just add the current node dot next, which is 6. I added it back, and again I came back here, min heap dot poll. I'll poll, and this will be removed, and taken it back here. It's kind of game. It will keep going on. 3 4, and then 3 4 will be added as the next element to the current element here. So 3 and 4, and then 3 4. The same thing will reflect here also in the dummy node. So once this is done, I'll do current is equal to current dot next, which is this 3, and I'll check if the current node dot next not equal to null. I'll add it back to the min heap, which will make it 4. Okay, this keeps going on. You can see this pattern. It's getting built up here in the dummy node, or the node that we had initialized. But the value we care about is from starting from the next element of the dummy node. This is the dummy node pointer pointing to. So the next element of the dummy node is building the entire output, and it will have all the elements in the sorted order. If we keep going this one, it will go forever. So let's return the dummy head dot next. So that will be the actual head of the sorted list, or the sorted linked list. So we can remove this, or we can keep it until we execute and make sure it works. If we have to reiterate or anything, return dummy head dot next list node. Where is the dummy head? Okay, dummy head. Okay, there's a typo. Dummy head. Okay, we haven't handled the empty list scenario. If there is a list is empty, then it's not even empty list. There is a list actually, but there is a null in that list. So we don't have to offer that one. If list dot is empty, then I think I can just return null. Let's see if that works. No, that doesn't. So what we can do? Oh, this is the primitive list. So lists dot length is equal to 0, or lists of 0 dot list of 0 is equal to null. Then return null. Okay. So now this one works. For the empty list, you can see there are two types of empty list. One is just a empty list. So this one is easy. This will be handled by list.length. I think in order to handle this one, the first element should be null. So I just added that there. So yeah, this works. Let's submit this and check. Oh, there is another case here. Output is given as, okay, there is an empty list, and then there is a 1. So I'm checking here, lists of 0 is null or not. I don't, should not. Okay, how can I check? How can we check this? Let's see, we will just add the node which is not null into this array here. Node not equal to null. Then only I'm adding it to the min heap. Like too much of filtering here at this point, or too many invalid inputs. So yeah, so now this one works. Okay, so this works. Let's remove all this commented code from here, and we can submit it again. Yeah, great. So this is a LeetCode hard, but trust me, it's not so hard. So it's fine. Another way we can sort this list is using, I think, how can we do this? let's get to that some other time. There might, but this is clear here. So let's leave it at this one, and this is optimal solution as well. And asymptotic runtime wise, we are just iterating through the list. We are visiting every node once, so it will be O of n. We must visit every node, and at the same time, storage or the space complexity wise, we are storing only the head of the linked list values, and for the output, if we consider, we are storing the head only. So this is also O of k, where k is even less than n, less than all the nodes. It is directly proportional to the number of linked lists given. So that is it. So this one is done deal now. Let's move on to the next problem. Or should we take a short break? So now next problem is, we are done with merge k sorted lists. We are done with this one. Did we do only three problems today? And then this one four. Okay. So group anagrams, that is a medium. Okay, next lot of them are medium until 53. Those are the important ones, most important ones. So let's take a short break here and let's join for group anagrams. Okay, I had not turned on the camera here, so that is bad. Okay, let's join after a short break. Let's keep the timer for the break so that everybody is informed about when I'll be back. Short break, 5 minutes, that should be good. And I'll hide myself behind the camera. Group anagrams. So let's reset this. Okay, I'm back now. I'm not able to hear the voice. So how can I do my voice test or mic test? Let me perform that once so that it is much more clearer. So mic test online. There might be something. Hey, how's it going on? Can you hear me? Hello. Can you hear me? Hello. Okay. Let me check it in the Zoom app. That should provide, I guess, some way of testing our mic. If there are settings in Zoom. Okay. Hey, can you hear me? So it's coming in red, showing in red. So hey, can you hear me? Hey, can you hear me? Hey, can you hear me? Hey, can you hear me now? Better? Is it better? Yeah. It looks awesome. Yeah, I see some few questions written in the few questions written in the chat there. So let's go through that once. Saddam has a question, so I did not see it when I was looking into that. Can you walk me through the thinking process again? In the first time, what are we doing to the heap? Do we add the item in each list in line 16 to 20? Okay, let's see. So the question that we were looking into was this merge case sorted list. So in this one, line 16 to 20, line 16 to 20. So this one. Okay, kind of these ones. So what are we doing here? That's your question, right? So here you can see this one as a linked list. So 145 is given, but it's represented as an array here, but it's not an array. It's a linked list here. So in the linked list, we just know what is the current node, what is the value of the current node. We do not know the value of the next node. We are able to see it because it is the linked list is represented as an array. That's a bit confusing. Again, saying so here it will look like if it is an actual real world case or real world instance, so it would have looked like something like this. The input mentioned here would have looked like this until we just point to that. So this would be xx, and this would have been xx, and this would have been x. So in each, this is an individual linked list, this is another individual linked list, and this is another individual linked list. We are just pointing to the head of the linked list now. So we can see only the head value. And you know how a linked list is represented, right? Linked list is represented with this node value. It has a value and a pointer to the next node. So we have the value and a pointer to the next node. So the first linked list would be something like, we just know until here actually. We do not even know it has three elements or whatever. We just know we have one, and there is the next element which is valid, that we can check if if the next one dot next is null or not, that we know. So there is a next value, and here for the second one dot next again, and for the third one we have two dot next. This is how we know the input. This is what we know about the input actually, not like this. So in the linked list, when it is represented as a list node, this is all we know. So it is in this format. So now what we are doing is we are adding these head nodes in the link, in every linked list, every individual linked list into the priority queue. We know the min heap. In the min heap, it is a single list node, and this is the list of list nodes. We don't want that, but we are taking a single list node or the head node, and we are adding it to the min heap. So we only have three nodes in this case, in this way. So we just know this node and this node and this node. I'm adding those three into the min heap. So I'm iterating through this list. So in this list, I'm taking the node. Actually, this represents a list node type. It doesn't represent the integer values here. It represents a list node type. I'm taking individual list node from array of lists, and then I'm just adding that node into the min heap. Is this clear? Or I can go to the whiteboard and try to draw the pictures for the linked list. Okay. Yeah, I hope this one is clear to you. So this is how the linked list works. So I mean, this lead code representation makes it a bit confusing. Like, don't read too much into how it is represented here in this one. Just focus on what is the input format given here. So in the input format given here, it represents it represents the list of list nodes. And how can we access it? We can access the individual list node in this format in the node. And how a node is represented, node just has a value and the pointer to the next list node. That's it. We do not know what is the value of the next list node or what is after that or anything. We just know that, okay, there is a list node, and that is list of list nodes is given. So that is only three list nodes are given. So three list nodes, all three list nodes, we are adding it to the heap, and it will look like this: 1 dot next, 2 dot next, and 3 dot next. So this is the heap that we have defined, let's say, or the min heap that we have defined. So 1 dot next, 2, 1 dot next, and 2 dot next. So this is how it is represented. Min heap will have the minimum value based on the value of the node, and then I'm checking, like here, I'm going through that min heap value, and I'm querying for the current node, and then I'm assigning that to current node. So current node is pointing to the dummy node, which is 0 as of now. 0 and null. It is represented like this, current node. So what I'm doing is current node dot next is equal to node. Current node dot next is equal to, I'll make it as this node, whatever I query. So I queried this one first. So node will become like this, 1 dot next. Next could be anything. Like, we will know that when we go to the next. So 1 dot next. Node will become 1 dot next, and we see here, um, min heap dot off, like what we did. Okay, we queried for the node, and current node dot next is equal to node. So current node dot next will become this one dot next as well. And then the same thing will be the dummy node as well. Our dummy head that we had defined, that was defined as 0 before, 0 to null, and that became the same way. Once this is modified, even it will be reflected in this one also, 0 dot 1 dot next. Now, okay, now current node is equal to current node dot next. Current node is equal to current node dot next. So current node will point to this one. So we will move to this one. Okay, current node is equal to current node dot next, and I'm checking current node dot next not equal to null. Current node dot next is not equal to null. There is a next value. If that is the case, min heap dot offer current node dot next. So current node dot next, by the problem here, we know that there is 4 and 5. So 5 is not yet known. So current node dot next is 4 dot next basically. So 4 dot next, how will we add it back to the min heap? So that will go here because current value is 4. 4 dot next, it will be like this. And then I'll query again min heap from the min heap. So that will give me this 1 dot next, and I'll remove it from the min heap here, and then 1 dot next, and I'll add it to the current node. That will be again 1 dot next, and it will be this one also 1 dot next. And then I'll check if the current node dot next is not equal to null. It's not equal to null. It is a 3 4 actually. So I'll add that 3 dot next into the min heap again. So that will come here. It will be abstracted away like this. It would have been in the abstracted form like this, 3 dot next. And then yeah, and then we repeat the same process. So now again I'll query for the node that would return this 2 dot next. We poll this one, so that gets out of the min heap, and it will be 3 dot next, sorry 2 dot next, and 2 dot next will be added. Current dot next will be is equal to that node, so that will be 2 dot next. That's the same thing is referenced here. And current is actually at this node, so current will become current dot node. Current was like this before. Current will become current dot next, which will refer to this one, and this will be deleted. Current will be pointing to this node, and then current dot next not equal to null, so I'll add it back to the loop. Current dot next is nothing but 6. 6 the value after 6 is null, so that is represented like this. 6 slash there is no next, so 6 dot null, 6 next null. And then again I'll come back. I'll query for the min here, so which will give 3 dot next. So that would give me 3 dot next here, 3 and next here, and that would be the current node. Current node dot next will be pointing to that, and then current node will become current node dot next, which will be, so when I point it that, this will become like this, and current node will be is equal to current node dot next. It will be 3, and then once 3 is there, current node dot next not equal to null. Current node dot next 3, there is a 4, so it will return 4 dot next. 4 dot next is nothing, so 4 dot null. So that will be added back to the queue here. So that will be like 4 null. That will be added back to the priority queue here. And now here in another one, let's take okay, and then this one will be 3 dot next. Yeah, this is right. So now it is 4 dot next. We will poll here. Let's complete this one. 4 dot next. 4 dot next will be added here. 4 dot next, and then that will replace this 4 dot next, and then I'll check if the next value is null or not. Next value is a 5 here, so I will just add that also into the back to the heap 5, and that will point to null. There's nothing after 5. And again I'll take 4 dot null as the next element, 4 and null. Okay, and then I'll check if here okay, current will point to 4, and then now I'll add this to the current dot next, 4 dot null, and then current is equal to current dot next. Okay, before that this will become 4 dot null, and current will become current dot next. Okay, and I'm checking current not text not equal to null, then only add to the priority queue. So this is removed from the priority queue already. So current dot next is not equal to null, add back to the priority queue, but it is equal to null, so I won't add it back to the priority queue. So this will be as it is. Again I'll see if the priority queue is not empty, then I'm querying from the next minimum element, which is 5 null. I'll take this out, and this will be 5 and null, and that would be the value in the current dot next, and current is equal to current dot next will point to this 5, and then this one also will be 5 null. And then here now again I'm checking if current dot next not equal to null, add it back, but it is null, so I won't add anything. And then again I'll query for the min. Here this will be 6 null, and this current dot next will be 6 and null, and current is equal to current dot next. and this one will be the same thing, 6 and null. So yeah, so now current dot next not equal to null, then add it back. Current not next is null, so I won't add it back. So that's it, and I'll check min heap is empty, so I'll come out of the loop. When I come out of the loop, I'm just returning dummy head dot next. Dummy head is pointing to the 0 dummy that we created. Dummy head dot next, we will return this value. Return this entire thing. This is the linked list that we are returning. Let's compare it with the output, or the expected output. So the expected output is 1 1 2 3 4 4 5 6. 1 1 2 3 4 4 5 6. This is the linked list that we are expecting. Yeah, and then there's nothing means 6 is pointing to null. That's it. So I hope I explained it thoroughly now. Let me know if you have any questions when you join back, Sadam. So next question. Let's go back to group anagrams. So here, group anagrams, this looks a little easier. So given an array of strings and group the anagrams together, you can return the answer in any order. So basically, eat, all these things are given. So anagrams means, I think the word formed by, an anagram is a word or a phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. So it should have the same set of words basically. So eat can be formed as TEA, ES, T as well, and then eight as well, ATE. So eight, eat, T. All these are anagrams. So all these words are given in this one, eat, T, eight. These are anagrams. We can group them and return it as a thing, as one of the list. And then nat and tan, those in the one list. And there are no anagrams with bat, so that is given as an individual list here. So that way we should group it. How do we do that? First thing is, I think we can sort individual strings here, and then we can sort, like once we sort it, we can before sorting it, let's take it into one of the hash map, and then we can use the sorted version as a key and the original word as the value. So something like this. Let's use a hash map. So in the hash map, key is a string of sorted value. So sorted value, let's say if we are taking eat, what's the sorted value of eat? So sorted value of eat is sort of eat, that should return 80. Okay. So, and what is the sorted value of t? So for the sorted value of t is also 8 only. So like this. And how should we represent it? So let's take a hash map and take the sorted value of as key and the list of original string as the value. So list of string as the value. And then we can group this list of strings and then return it as output. It will become list of strings. So here grouped anagrams. Whenever there is a grouping or anything, hash maps works perfectly. Okay, let's see this one. Okay, I initiated a hash map, and now next thing is grouping the character, grouping the words. So before that, we can start iterating through the string str and strs. So that's the list of string. I'm iterating through that string. So string sorted version is equal to str current string dot, or yeah, we can take string dot to char array and then we can sort it, I guess. Arrays dot sort of string to char array, and then we can convert it into convert it back to the string by string dot value of, or new string, also new string, but we can pass the char array in order to initialize this value. Okay, we are forming the new string, which is the sorted version, sorted string. Okay, and then this will be the key and this will be the value. So what shall we do here? So map dot put. So map dot put string, but what if it already exists? If already exists, and if there is a value, like let's say I already added eat. When I came to eat, okay, I didn't have anything in the array. So what should I do? I'll do string, and then I'll do not string, sorted string, and then it will be like new array list dot add, and then what I can do is map dot get sorted string dot add this this original string into that list once I get this array list. Okay, so now let's say I came to this t. So now t, the sorted string is the same thing. It will give this 8 only. So now in this case, the sorted string, I'm defining new array list that would just remove the string altogether. So what should I do is, I should either do it this way. If map dot does not contains key sorted string, if it does not contains the key sorted string, then add this value or put this value. Okay, then I'm just creating a new array list in front of that. And if it does not contain, I'm initializing a new array list and then adding it to the array list. If it contains, I'll just go and directly add it to that array list. So that's how I'm uh, creating a group. Now let's say if I print this one, just to give you a visualization. So grouped anagrams. For now, new array list of grouped anagrams dot values. Okay, okay, this is the method name to char array, and this one is grouped anagrams, not just a map. Same here. Let's mark it as this one. Char string. Okay, and okay, to char array. Okay, this method, this is returning null here or void here, so it's not doing anything. Let's just sort it outside, and then let's just provide the string dot char array here. String char array. This is sorted. And what's the problem with this? Contains key. It's not keys, contains key. Okay, so this one looks like it's working now. Let's see. Yeah. So let's see the what we printed here. So if we see whatever we have printed in the output, it is grouped in the hash map this way. AET, not ATE. Sorry, I was showing ATE. AET is the sorted order, and then that is grouped under, like, these, all these words are grouped under this sorted version AET, and this is grouped under this sorted version ABT. These two are grouped under sorted version ANT, and I'm just returning these values as the output, which were grouped there. I'm just not returning the key there. So that's about it. So if the interviewer is not familiar with Java, then yeah, this is AT will become not ATE, it is ATE, AET. Nobody pointed it out. Yeah, this is AET. So the interviewer is not well versed with Java, then write the code that we just wrote. So just define it if group anagrams not equal to key and all this one. If it does not contain key, initialize it and create a new array list, or otherwise add it to the existing array list. If interviewer is well versed with Java, then we can use this shorthand methods that is provided, like this group anagrams dot put uh, or compute if absent, I guess. Yeah, compute if absent. Compute if absent for this sorted string. What should we compute and add? If it is absent, if the value is absent for the sorted string, then we will compute and create a new array list of string. Okay, and then the operation performed should be to add to that string. So to add to that array list, what are we adding? Adding the current string, and close this one. This should work as well according to me. Incompatible parameter in lambda expression. Group anagrams sorted. Okay. Oh no, not this. Okay, there should be a value also provided. Yeah. So compute if absent. Let's look into the in Java, into the documentation of this. So in the compute if absent, okay. So let's see here, compute if absent, Canada, and there is a value. Then I will use that value. I can use that value as also. So Toronto of K plus capital cities. So K refers to the data type of the keys of the map. K is the key and function. And function required. A function object or lambda expression which computes the value of the entry. The function has one parameter containing the key of the entry. So I can compute anything based on the key. So here, I'm not computing it based on the key because I know the value here. So I'm not using the value, but I could have computed it based on the key as well. Like let's say I wanted to sort it, and like, let's do it this way: private string sort string, or sort string of string s. Okay, so into this one, I could have done it somewhat this way. Okay, this is a better way, I guess. So now that's the use of benefit of reading documentation. Let me see, I'm excited. So now let's make it as str only, just for compatibility. Okay, string to char array, I converted it, and then returned sorted string. Instead of that, I can just return it, return the sorted string. So this should return the sorted string. Now I have the value or the string, whatever the sorted string is. Oh, if the string was the key and the sorted string was the value, then I could have done that. Now I cannot actually. I need the sorted string as the key. Like I have computed the key here. So yeah, basically I need this. I mean, I just modularize it now. So I can just modularize it this way, or I can just call this method sort string of str. Yeah, and then value will be as it is. This will be the key, and this will be the value. Okay, here we see the values in the map are as it is. So this is a much lesser effort. Like I'm not checking like all that checking if the value for that key is null or not. All that is happening in a single line. So power of using that compute is absent. So okay, there are few comments. Let's see. If hash map not contains key, we created new array list and added to the hash map, but seems like we have not added current string to that new array in the commented code. Here we have added at the end. If you see here, uh, we have added here dot add of string. So yeah, you have mentioned, you have understood. So yeah, so in the same line, we are checking if the array list exists for that key or not, and then we are adding the value for that. In the other syntax, we had written four lines of code where we will check if the value for that key is null or not. If it is null, then we were creating a new array list and then coming out, and then irrespective if it's null or not, I was just doing the get value for that particular string and then adding value to that, or adding string to that list. So now it is happening in the same line. So that's about it. There's nothing more complicated here. So I'm grouping anagrams based on the sorted version of it, and then I'm just returning the output. I can remove this println statement and try submitting it. Okay, this works. So let's move on to the next problem. Before that, what's the time now? Okay, let me see how many we covered. Group anagrams is done. 49. I'll just enter this into the sheet of the journal if we haven't. Yeah, we haven't. So let's add this one also. Okay. Did we add all the other columns? Meeting rooms, merge, create, sorted list. Okay, we haven't added the meeting rooms. That's why it's so meeting rooms is not added. So let's add that also. Okay. So yeah, today we are kind of done with 5 problems, and only one of them was easy, the one we started with, and rest are medium. Yeah. Let's get to the next problem, which is rotate an image. This is kind of tedious problem for the mindset that I have. As of now, I need to keep track of a lot of syntaxes. Let's move on to the next thing. Or let's just take a break. Let's get refreshed for 10 minutes and then come back. So yeah, I'll just refresh this one. Let's see if we have covered everything from the beginning based on frequency, reverse frequency. Yeah. So all these are covered. Group anagrams are done. Okay, today the frequency is a little different, I guess. So we are done with two some number of islands merge into a long palindrome longest substring without repeating characters. Yes, we are done with that. And then meeting rooms two, group anagrams are done. Spiral matrix system, climbing stair system. We are not done with the threesome, and we are not done with this maximum subarray. We are done with the merged k sorted list though. Okay, so let's go with the threesome and then maximum subarray after the break. Let's do those two problems and then see. We can start the session in the evening after these two problems are over and finish off some 7 more in that session as well. If you are still in the session, try to revise the previous problems. If you don't want to take a break, I'll just take 10 minutes break and we'll be back. Okay, it's showing 20 minutes, but I'll be back in 10 minutes. Did I forget to turn on the camera today also? Yes. So remind me if I don't have the camera turned on or if my voice is not clear or anything. Hey everyone. So I apologize for this. So I might have to leave now and end the live stream. But I'll be back in the evening again with another live stream. We'll continue solving the blind 75 problem only. Okay, what's the state now? Our state currently is okay. We have solved 12 problems. So yesterday 7 and 5, today effectively are 8 and 4. So in the evening again, let's try to at least target, like, at least we should be done with 15. That's minimum expectation no matter what. If possible, let's try to get to 20 problems. That's aggressive, but still, that is doable, I guess. I wanted to complete it over the weekend, but it's looking like a difficult task now. But yeah, nevertheless, it's not impossible. Let's keep grinding as and when we get time. And whenever you get time, just watch the video or watch the recording and let me know if you have any questions about it. I'll make sure to answer that either in the comments, or I can make a separate video for that, or I can dedicatedly call you or text you and explain it if you are not sure with the concept. So until next time, yeah, keep grinding. See ya.